Hi, in this video we're going to talk about triangle congruence theorems. Okay, so sort of very similar to what we spoke about most recently, congruent triangles. This one we're going to talk about multiple theorems that will lead us to prove that triangles are the same or they are congruent. If you haven't subscribed, go ahead and click on that right now. Click the like button and let's get right to it. So these are the different theorems we're going to be talking about today. We're going to be talking about 5 different theorems to prove triangles are congruent. We started with this in our last video, most recent video. The CPCTC theorem says that if you're given all of the angles are the same and all of the sides are also the same, at least the corresponding ones, right? If I have all of this information, the sides, the angles, if I know everything about them is the same, then these triangles are congruent. Well, ideally we know all 3 sides and all 3 angles. But having all that information is not always going to happen, and it truly isn't necessary. You only need 3 things. You only need to know 3 different things from these 2 triangles to prove that they're the same. And that's what these next theorems are about. So if you have something to write with, go ahead and take it out. And let's take some notes. Let's get to it. This theorem is called the side-side-side theorem, initialed as SSS. And the reason why it's called a side-side-side is because we're given this side right here is congruent to this other side with 1 tick mark. The double tick mark is also a side that's being the same, and this one is also the same as well. So if all 3 sides are the same for the triangles, the angles are automatically assumed to be congruent. This theorem is called side-side-side, or SSS. This next one is called side-angle-side. Notice how we have these 2 sides being given to you. We have an angle, we have an angle between these 2 sides being given. So this theorem is showing side-angle-side. If you know the angle between the 2 sides, then the other missing information should also be congruent. This next one is called angle-angle-side. Notice how we're given 2 pair of angles that are adjacent to each other and 1 side that is on the left, or sorry, on the side of it. So here we have angle-angle-side. And then we have angle-side-angle. I know that these words can sound very similar. Angle-side-angle, side-side-angle, angle-angle-side, right? They all have the same variables, or the same initials. But the order is what is important here. Here we're given an angle, a side, and an angle, side, and an angle. Notice how the side is between the 2 angles. In the previous example, the angle was between the 2 sides, right? Or we had an angle side in the previous example. For example, we had an angle, another angle, and then the side. So notice how in this scenario, the side is not right between it. So it's not angle, side, angle. It's angle, angle, side. The order of the letters matters. Here, the side is sandwiched between the 2 angles. Here, the side is not. That's why this one is angle, angle, side, while this one is angle, side, angle. And then the only one theorem that does only require 2 things is called a right triangle. The hypotenuse of a right triangle will always be right across diagonally from the right angle. This is called the hypotenuse. The hypotenuse. If you have a right triangle, this is the first theorem that I always check. Am I given the hypotenuse, and am I given one of the legs of the triangle? If I know the hypotenuse and one of the legs, then we use hypotenuse leg as a theorem to prove that they're the same. I don't need 3 sides or 3 angles or angle side angle. We don't need any of that. We just need to know that it's a right angle and then hypotenuse and the leg. Now, we do have two situations where they're not theorems, okay? And we're going to talk about these next. There's two possibilities or combinations of letters between angles, sides, and angle, side, angles, and angle, angle, sides. There's two combinations, where these three letters are not going to work for you. And here we have angle, angle, angle. And the reason is this. I can construct an angle, say 50 degrees. The length of the sides do not change the measurement of the angle. The angle is the distance or the degree between the two angles. So I can choose to make a triangle very small or very large. The angles do not determine congruence. They do not show that they're the same. If anything, they show that they are similar to each other. So if we know that we have three angles that are congruent for both triangles, we cannot prove congruence. We can say they're similar, but they're not congruent. So angle, angle, angle does not work. And the other one that does not work is when you're given an angle and two sides. An angle and two sides. And if you read that, I wrote it backwards, but if you read that, that should be like a red flag, right? Side, side, angle does not work, or angle, side, side. Because I can always take this leg, and I'll highlight it here for you. I can always take one of these legs and just open it up. Keep the same length, open it up, and these triangles are clearly not the same. So, angle, side, side, also not a theorem. So if you can remember the last one and this one, angle, 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 and side, side, angle, or angle, side, side, these two theorems are not going to work. Now, the best way to learn these rules are to practice them. What I like to do is I'm going to do two things when I'm seeing a picture. I'm going to label the tick marks or the arches that I see. Okay, that's one thing that I'm going to be doing for sure. So if I see markings on my picture, like I have side markings, those are the same, these are the same, and these are the same. Now I can look at the triangle and say, oh, well, I'm given all three sides. So the theorem being used here is side, side, side. On the picture on the right, I'm only given two things. I'm given an angle, another angle, and that's it. It's kind of weird, right? But if two triangles are touching each other and they're back to back, then this side is also going to be congruent. Because if both triangles share the same side, then by default it'll be the same. So notice how they both have angle, angle, side. If I ever have a picture where two triangles are touching back to back, I'm always going to make that marking. Here, because they're touching back to back, I'm going to put a marking there. Notice how I have an angle, a side, and an angle. Therefore, this one is called angle, side, angle. Over here, I have a side, an angle, and a side. Side, angle, side. Notice how the angle is between the two sides. So it's called side, angle, side. Again, the order is important. This picture on the left, they both share a side. So I'm going to put another tick mark here. And I have angle, side, side, or angle, side, side. This should be a red flag for you, right? ASS, if you say that out loud, that's how you can remember that this is not a theorem. Not congruent. On this other one, I'm given angle, a side, and an angle. And at the same time, I'm given an angle, and a side. Notice how these two are also not congruent. Because this triangle on the left says angle, side, angle. But the triangle on the right says angle, angle, side. They need to show the same congruence in this picture. So this is another example where they're not congruent. Here I also have, I'm given all three angles. Angle, angle, angle is also an example of not congruence. Not gonna work. If I label this other picture, I have a side, an angle, and a side, an angle, and a side. They're both sharing side, angle, side. All right, for these last two examples, they both share a side here, so I'm gonna put my tick marks. Notice how I have a side, and an angle. I have a side, this side, and an angle. However you read this, ASS or SSA, ASS is not a theorem, not congruent. And then on this other one, I'm given an angle and a side. The thing I want to show you here is that we have vertical angles. Vertical angles are always congruent. They're right across from each other. If I ever see, like this scenario, two triangles sharing a side, I'm going to mark it. If I see vertical angles, I'm also going to mark it because that's always going to be congruent. Vertical angles are always congruent. So now if I look at my triangle, notice how we have angle, angle, side. Angle, angle, side. And that one is a theorem. So my best pointers for you for here is to do this. If you see vertical angles, draw the arches in there. If you see two triangles sharing a side, draw the tick marks for the side. And then once you label your angles, your sides, and your angles, just read the problem. Read the letters. ASS, ASA, SAS, SSS, and that's how you know which theorem is going to go with which one. And as long as you remember that there are two theorems that do not work, two of them, all right? I'll write them here on the side. Angle, angle, angle does not work, and angle, side, side. These are not theorems. So if you see those two scenarios, not congruent. Everything else is good to go. All right, let me know if this helped. Click the like button, subscribe, and as always, we'll calculate later.